Hey everyone, and welcome back to AI Paper Podcast. Today we're diving into something pretty wild, SWE Lancer. Can frontier LLMs earn $1 million from real-world freelance software engineering? By OpenAI.
Ooh, that's a mouthful.
It is. Trust me, it's worth it. This paper takes these cutting-edge AI models and throws them into the real freelance jungle of Upwork.
Like lions and tigers and AI, oh my.
Exactly. They're using tasks from Expensify's open source repo, so we're talking 1,488 tasks, and a potential to earn $1 million. Think bug fixes, feature implementations, you name it.
So they're really trying to see if AI can hack it as a freelancer.
That's the big question. The researchers even tested how well AI can act as a manager, picking the best proposals from real freelancers. It's like a real-life Turing test for software engineering.
So buckle up, folks. We're about to find out if AI can make serious bank in the world of freelance coding.
Okay, so let's break down this paper. What makes it so unique?
Well, it really sets itself apart from those typical coding benchmarks that just use made-up data pets in unit tests. SWE Lancer uses real-world freelance tasks with real payouts attached.
So instead of testing in a lab, they're throwing the AI into the wild.
Exactly. This gives us a much better idea of how these models would actually perform in a practical setting, not just some theoretical vacuum.
So it's like judging a chef not by their recipe book, but by the actual dishes they can cook.
Exactly. It's all about real-world performance.
Okay, so right off the bat, the million-dollar question, did any of the AI models actually hit that mark?
Haha, well, spoiler alert, no, they didn't. But the best one was Anthropic's Claude 3.5 Sonnet. It got a 26.2% pass rate on what they call individual contributor tasks. Those are things like writing code to fix bugs or implement features.
And what about those manager tasks?
Well, Claude did even better there with a 44.9% pass rate. It seems like evaluating code is a bit easier for these models than actually writing it, at least for now.
That's actually a really interesting finding. It suggests that AI might be better suited for tasks that involve analysis and judgment rather than pure code generation at this stage.
I think that's a key takeaway here. AI might not be ready to replace developers entirely, but it's showing real potential for augmenting their work.
Imagine AI tools that can help developers evaluate code quality, assess risk, or even provide feedback on design choices. It's a glimpse into a future where AI and humans work side by side.
Absolutely. And the paper dives deeper into this too. They looked at how the models perform when they're given multiple tries to solve a task, what they call pass at K.
So it's not like they have to nail it on the first try.
Right. And they found that allowing for multiple attempts significantly improves those success rates.
It's like giving the AI a chance to learn from its mistakes, which is pretty realistic.
Exactly. Developers don't always get it right on the first try either. And another cool thing they looked at is how access to a user tool affects performance.
A user tool? What's that?
It's basically a way for the models to simulate user interactions. It lets them see how their code changes would actually behave in a real environment.
So like a virtual testing ground.
Exactly. And guess what? The models that used this tool effectively tended to do better. It's like they were able to test and refine their work in a more realistic way.
That makes a lot of sense. Debugging and iteration are such crucial parts of software development. It's not just about writing perfect code from the start, but about constantly testing, refining, and iterating.
It seems like these AI models are starting to grasp those principles.
So while this paper throws AI into the deep end of freelance work, it's also revealing some of its current limitations. It's clear that AI is evolving rapidly, but it's not quite ready to take over the world of software engineering just yet.
I agree, but it is a fascinating glimpse into the future. And to really understand these findings, we need to unpack the SWE Lancer benchmark itself.
Yeah, what makes this benchmark so special?
Well, it's all about real-world relevance. SWE Lancer uses those real freelance tasks we talked about from Expensify's open source repository.
And each of these tasks comes with a real payout attached.
You got it. They range from a quick $50 fix to a much more complex $32,000 feature implementation.
Wow, so the difficulty gradient isn't arbitrary. It's directly tied to the market value of these tasks.
Precisely. And that's what makes SWE Lancer so unique. It provides a market-driven measure of difficulty based on actual economic value.
It's like testing an athlete not just on their speed, but also on how much they can earn from their skills.
Exactly. And the evaluation process is just as rigorous. Forget those simple unit tests. They use end-to-end tests that are created and verified by professional software engineers.
So they're really trying to mimic the comprehensive review process that freelancers actually go through.
They even use browser automation to simulate user interactions, making sure that the AI's code changes are tested in a way that mirrors real-world usage.
That's impressive. So they're really going all out to make this as realistic as possible.
They are. Now, the paper focuses on two main types of tasks: individual contributor tasks and management tasks.
Let's break those down. What are the models actually being asked to do?
So for those individual contributor tasks, the models are given a real issue description from the Expensify repository. They have to understand the problem, navigate a complex code base, and actually come up with a solution that works within that existing system.
It sounds pretty challenging.
It is. And for the management tasks, things get even more interesting. Here, the models are presented with several proposed solutions for an issue. Real proposals from real freelancers when that issue was originally posted.
So it's not like they're comparing idealized solutions, they're looking at real-world code with all its quirks and imperfections.
Exactly. And their job is to pick the best one from the bunch, just like a technical lead would do.
Wow, so they're not just coding, they're actually making decisions about which solution is the most feasible, maintainable, and aligned with the project goals.
Right. It's a much higher level task, and it really tests the model's ability to think like a software engineer.
It's like they're stepping into the shoes of a senior developer.
Precisely. Now, speaking of the models, they put 3 state-of-the-art LLMs to the test: OpenAI's GPT-40 2024-0806, OpenAI's O1 model with high reasoning effort, and Anthropic's Claude 3.5 Sonnet.
A real lineup of heavy hitters. And as we mentioned earlier, no one hit that million-dollar jackpot, but we did see some intriguing patterns.
Yeah, like the fact that the models consistently did better on those management tasks than on the individual contributor tasks. It seems like evaluating code is a more manageable feat for AI than actually generating it at this stage.
And remember that pass-a-K thing we talked about, giving the models multiple attempts to solve a task.
Right. Well, that's significantly boosted their success rates.
It suggests that these AI tools might be most effective when used iteratively, giving them a chance to refine and improve their solutions over time.
Exactly, just like human developers.
And that user tool also played a role. The models that used it strategically tended to do better.
It's like they were able to learn from their virtual experiments and come up with more robust solutions.
So while AI isn't ready to take over the entire world of software engineering just yet, it's clear that it's evolving rapidly and its role is only going to grow in the coming years.
Absolutely. And this research provides a valuable roadmap for understanding where that evolution is headed and what challenges we still need to address.
So let's dive into some of the specific insight from the paper. What are some of the things that these AI models were surprisingly good at?
Well, one thing that stood out was their ability to localize code. They were really good at finding the exact section of code that was relevant to a particular issue.
It's like they had a built-in code radar.
Exactly. But they did struggle with understanding the root cause of the problem. Often they would come up with patches that addressed the symptoms without really understanding the underlying issue.
So they could fix the bug, but maybe not in the most elegant or sustainable way.
Right. It suggests they lack a deep understanding of complex software systems and how all the pieces fit together.
It's like fixing a leaky faucet by wrapping it in duct tape. It might work in the short term, but it's not really addressing the underlying problem.
That's a great analogy, and that seems to be one of the key limitations of these models right now. They can analyze code and even generate fixes, but they haven't mastered the art of understanding the system as a whole.
So for our audience of developers out there, what does this all mean? What skills should they be focusing on to stay ahead of the curve?
I think a deep understanding of system architecture and design principles is going to be more important than ever. In a world where AI can handle some of the more routine tasks, it's going to be the human developers who can see the bigger picture and make strategic decisions who will be most valuable.
So it's not just about being a code monkey anymore. It's about understanding the why behind the code and being able to think critically about the overall design and impact of a software system.
Right. Now, another interesting finding from the paper was the importance of multiple attempts, or pass at K, in improving the model's performance.
We talked about that a bit earlier, but why is that so significant?
Well, it suggests that the future of AI-assisted software development might not involve one-shot code generation, but rather an iterative process where AI tools and human developers collaborate to refine solutions over time.
It's like having an AI pair programmer who can help you explore different options, test code, and make sure you're not introducing new problems.
Exactly, and it aligns with how real-world development actually works. We rarely get things perfect on the first try. It's all about testing, iterating, and learning from our mistakes.
And speaking of real-world relevance, let's talk about that user tool again. Why was that such an important part of the study?
Well, it gave the models a chance to see how their code would actually behave in a more realistic environment. It's like giving them a sandbox to play in and experiment.
And it seems like the models that used the tool effectively tended to perform better.
They did. It suggests that they were able to learn from those virtual interactions and develop more robust solutions.
So even though AI isn't ready to take over the freelance world just yet, we're seeing glimpses at its potential. And this research gives us valuable insights into what that potential might look like.
Now, to really dive into some of the specific, let's look at some of the anecdotes from the paper that show how these models tackled individual tasks.
That sounds fascinating. Give us an example.
Well, one compelling example involved a task where the model had to fix a bug that was preventing a validation error message from appearing.
Oh, I've definitely encountered those kinds of bugs before. It's always the little things that trip you up.
Right, but what was remarkable was that the model not only found the relevant code section, but also tried to reproduce the bug using the user tool.
So it was actually engaging in a basic form of debugging.
It was. It wasn't just blindly applying a fix. It was trying to understand the problem and make sure its solution actually worked.
That's pretty impressive.
It is. It suggests that these models are starting to internalize the debugging process. They're moving beyond code generation and into the realm of testing and refining their solutions.
That could have huge implications for the future of software development. Imagine AI tools that can automatically generate test cases and find potential bugs before they even make it into production.
Now, another fascinating anecdote involved a task where the model had to choose between different proposed solutions for implementing a feature.
It's like that management task we were talking about earlier.
Exactly. And what was interesting here was that the model didn't just pick the solution that seemed technically correct. It also considered things like the complexity of the code, the reliance on third-party libraries, and even the overall design principles of the app.
So it was thinking about the bigger picture, not just the immediate problem.
Precisely. It was trying to make a decision that would be best for the project as a whole, not just the easiest or quickest fix.
That's what you'd expect from a seasoned developer.
Right, and it shows that these models are starting to develop a more holistic understanding of software development.
This is all really exciting stuff. But of course, every research project has its limitations. What are some of the things that the researchers acknowledge as potential areas for improvement?
Well, one key limitation is that the tasks in SWE Lancer all come from a single repository, Expensify. While Expensify is a real-world project, it's still just one example.
So it's possible that the findings might not generalize perfectly to other types of software projects with different coding styles and complexities.
Right. Further research is needed to see how well these models perform across a wider range of software domains.
Makes sense. What else?
Another limitation is that these freelance tasks might not fully capture the complexity of full-time software engineering roles.
Yeah, freelancers often work on more self-contained projects, while full-time developers are dealing with the long-term planning, architecture, and maintenance of large-scale systems.
Exactly. SWE Lancer is a great benchmark for evaluating AI's ability to tackle real-world coding challenges, but it's not the whole picture of software engineering.
So it's a valuable piece of the puzzle, but there's still a lot more to explore.
Absolutely. And another limitation that the researchers acknowledge is that the models are currently limited to text-based input. They can't process visual information like screenshots or videos, which human developers often rely on.
That's a good point. Imagine trying to debug a complex user interface issue without being able to see the interface itself.
Right. Incorporating multimodal inputs like images and videos could significantly enhance the model's abilities.
It would be like giving them another sense to perceive the world of software.
Exactly, and that's actually one of the directions for future research that they're excited about.
So they're already thinking about how to push these models even further.
They are. They also want to explore the economic impact of AI in software engineering. How will these models affect productivity costs and even the job market itself?
Those are some big questions.
They are. And SWE Lancer provides a framework for starting to answer them. It's a starting point for understanding how AI might reshape the software industry in the years to come.
And it's not just about the economics. We also need to consider the ethical and societal implications of AI in software engineering.
Absolutely. How do we ensure that these tools are used responsibly and ethically? How do we prevent bias and discrimination? These are all critical questions that we need to address as AI becomes more integrated into our work.
It's a call to action for everyone in the field to think critically about the role of AI and to work together to shape a future where technology serves humanity.
I couldn't agree more. It's an exciting time to be working in software engineering. We're at the forefront of a technological revolution, and it's up to us to guide it in a positive direction.
So as we wrap up this part of our deep dive into SWE Lancer, I want to leave our audience with a few key takeaways. First, AI is not about to replace human software engineers entirely, but it is transforming the way we work.
Right. Second, the skills that are most valued in software engineers are evolving. A deep understanding of system architecture design principles and the ability to think critically are going to be more important than ever.
And finally, we need to be mindful of the ethical and societal implications of AI and work together to ensure that it's used responsibly and for the benefit of all.
I think that's a great place to pause for now. We've covered a lot of ground, and I'm excited to dive into some more specific examples and insights in the next part of our deep dive.
Me too. Stay tuned, everyone.
It's like they had this uncanny ability to zero in on the problem area, almost like a detective with a magnifying glass. They could pinpoint the exact code snippets that needed attention.
That's impressive. But you mentioned earlier that they struggle with understanding the root cause of the issue. It sounds like they could apply a fix, but not necessarily understand the why behind the problem.
Exactly. It's like treating the symptoms without addressing the underlying disease. They could patch up the code, but not necessarily grasp the deeper systemic issues that might be causing the bug in the first place.
So they're like code surgeons who can stick up a wound, but maybe haven't quite mastered the art of diagnosis.
A very apt analogy, and that's where the current limitations lie. They can analyze and even generate code, but they haven't quite cracked the code of true system understanding, that intricate web of dependencies and potential ripple effects that experienced developers are so attuned to.
Right, fixing a bug isn't always a straightforward process. Sometimes it's like untangling a knotted mess of yarn. You need to understand how everything is connected before you start pulling on threads.
Precisely, and that's a key takeaway for our listeners. As AI tools become more integrated into the development workflow, understanding system architecture and design principles will be absolutely crucial.
So it's not just about writing code anymore. It's about understanding the bigger picture and thinking strategically about how changes will impact the entire system.
Absolutely. The ability to anticipate those unintended consequences, to see the potential pitfalls before they arise, that's what will separate the truly skilled developers from the pack.
And the paper highlights another intriguing aspect of AI's performance, the fact that giving the models multiple attempts to solve a task significantly improves their success rates. Why is that finding so significant?
Well, it suggests that the future of AI-assisted development might not be about one-shot code generation. It might be more about an iterative process, a back and forth between human developers and AI tools where they work together to refine solutions over time.
So it's not about AI replacing humans, but rather augmenting their abilities, kind of like an AI apprentice learning from a master craftsman.
Exactly. And this makes sense, right? Think about how human developers work. We rarely nail it on the first try. We test, we debug, we iterate until we arrive at a solution that's not only functional, but also elegant and maintainable.
So those multiple attempts, those pass-it-case scenarios, they're actually a more realistic reflection of the software development process.
They are, and this approach aligns well with the agile methodology that's become so prevalent in software development. It's all about embracing iteration, feedback, and continuous improvement.
And speaking of real-world scenarios, let's revisit the user tool that we discussed earlier. Can you remind us why that was such an important element of the study?
Of course. The user tool essentially gives the models a virtual playground, a simulated environment where they can test their code and observe how it behaves in a more realistic setting.
So it's like giving them a chance to play with their code and see how it interacts with the rest of the system.
Exactly. And the results were quite telling. The models that effectively utilized this tool generally performed better. It's like they were able to internalize the importance of testing and debugging, just like human developers do.
So it seems like AI is starting to grasp some of the fundamental principles of software development. That's pretty encouraging.
It is. Now let's delve into some specific anecdotes from the paper. These real-world examples offer fascinating insights into how these models approach problem solving.
I'm all ears. Give us the juicy details.
All right, one particularly compelling anecdote involved a task where the model had to fix a bug that was preventing a validation error message from displaying correctly.
Oh, I've definitely been there. Those seemingly simple validation errors can sometimes be the most frustrating to track down.
They can be, but what was remarkable in this case was that the model not only pinpointed the problematic code section, but also attempted to reproduce the bug using the user tool, effectively verifying its solution before submitting it.
So it was engaging in a basic form of debugging, not just blindly applying a fix.
Precisely. This suggests that these models are starting to develop a more sophisticated understanding of the debugging process, moving beyond mere code generation to actively test and refine their solutions.
That's a huge step forward. It hints at a future where AI tools could play an even more active role in software testing, potentially saving developers countless hours of manual debugging.
I agree. Now, another intriguing anecdote involved a task where the model had to choose between several proposed solutions for a particular feature implementation.
This sounds like those management tasks we discussed earlier, where the models had to evaluate and select the best solution from a pool of real-world proposals.
It is, and in this specific instance, the model's decision-making process was particularly insightful. It didn't simply opt for the technically correct solution, it also factored in things like reliance on third-party libraries, the complexity of the proposed changes, and even alignment with the app's overall design principles.
Wow, so it was thinking holistically about the project, not just focusing on the normal problem at hand.
Exactly. It was taking into account the broader context, the long-term implications of its choice, just like a seasoned developer would.
That's really impressive. It suggests a level of understanding that goes beyond mere code analysis. It's about grasping the nuances of software design and making decisions that benefit the project as a whole.
And that's a key takeaway here. As AI tools become more sophisticated, they're not just going to be about automating tasks, they're going to be about augmenting human intelligence, helping developers make better decisions, and ultimately creating better software.
This is all really exciting stuff, but of course, every research project has its limitations. What are some of the caveats that the researchers acknowledge in this paper?
Well, one key limitation is that the tasks used in SWE Lancer all come from a single source, the Expensify repository. While Expensify is a real-world project, it's still just one example, and it's possible that the findings might not generalize perfectly to other types of software projects with different coding styles, conventions, and complexity levels.
So it's like testing a fish's swimming ability in a controlled tank. It doesn't necessarily tell you how it will fare in the vast ocean.
Precisely. Further research is needed to assess how these models perform across a wider range of software domains to truly understand their strengths and weaknesses.
That makes sense. What other limitations do they highlight?
Another important consideration is that the freelance tasks used in SWE Lancer might not fully represent the complexities of full-time software engineering roles.
Right, freelancers often work on more isolated tasks, while full-time developers are typically involved in the long-term planning, architecture, and maintenance of large-scale systems.
Exactly. SWE Lancer provides a valuable benchmark, but it's important to acknowledge that it doesn't necessarily capture the full scope of software engineering with all its intricate nuances and challenges.
So it's a valuable snapshot, but not the entire picture.
Right. And another limitation that the researchers acknowledge is that the models are currently limited to text-based input. They can't process visual information like screenshots, videos, or interactive user interfaces, which human developers often rely on to understand problems and design solutions.
That's a great point. Imagine trying to debug a complex UI issue without being able to see the interface itself. It would be like trying to solve a jigsaw puzzle with half the pieces missing.
Exactly. Incorporating multimodal inputs such as images and videos could significantly enhance the model's ability to understand and solve a wider range of problems, bringing them closer to the capabilities of human developers.
So it's about giving them a more complete picture of the software world, allowing them to perceive and interact with it in a more human-like way.
Precisely, and that's actually one of the key directions for future research that the authors highlight. They're excited about exploring how multimodal inputs could unlock even greater potential in these AI models.
So they're not just resting on their laurels, they're already looking ahead to the next frontier of AI-powered software development.
They are, and another area they're keen on exploring is the economic impact of AI in software engineering. How will these models affect productivity, costs, the job market itself? These are crucial questions that need to be addressed.
It's like we're standing at the edge of a new technological era, and we need to carefully consider how these advancements will shape the landscape of software development and the broader economy.
Absolutely. SWE Lancer provides a framework for starting to grapple with these questions. It's a first step towards understanding the potential transformative power of AI in this field.
And it's not just about the economic implications, right? We also need to think about the ethical and societal impact of these technologies.
You're absolutely right. As AI tools become more powerful and pervasive, we need to ensure that they're used responsibly, ethically, and for the benefit of all, not just a select few.
So it's a call to action for everyone involved in software development, from researchers and developers to policymakers and educators. We need to have a thoughtful and nuanced conversation about the role of AI in our field and work together to shape its trajectory in a way that benefits humanity as a whole.
I couldn't agree more. This isn't just a technical challenge, it's a societal one, and it requires a collaborative effort to ensure that these powerful technologies are harnessed for good.
That's a great point. So as we wrap up this part of our deep dive, let's leave our listeners with a few key takeaways to ponder. First, AI is not about to replace human software engineers, but it is transforming the way we work, and the skills that will be most valued in the future are evolving.
Right. Second, we need to think holistically about the impact of AI in software engineering, considering not just the technical aspects, but also the economic, ethical, and societal implications.
And finally, this is a call to action for all of us to engage in a meaningful dialogue about the role of AI in our field and to work together to shape a future where technology serves humanity, not the other way around. So we've really explored the ins and outs of SWE Lancer, how it works, and what it tells us about the current state of AI in software engineering. It's clear that AI is making some serious progress. But like you said, it's not about to replace human developers entirely.
Right. It's more about a shift in focus. AI seems to excel at those tasks that involve analyzing code, evaluating solutions, finding those needle in a haystack bugs. But when it comes to understanding the bigger picture, the why behind the code, that's where human expertise still shines.
It's like AI is a master chess player, capable of making brilliant tactical moves. But it's the human player who understands the overall strategy, the long-term implications of each move.
That's a great analogy, and it brings up a key question for our audience. As AI tools become more sophisticated, how will this change the role of the software engineer? What skills will be most valuable in this evolving landscape?
Yeah, that's something I've been thinking about a lot. It seems like we might see a shift towards a greater emphasis on higher-level skills, things like system architecture, design thinking, strategic decision-making.
Absolutely. As AI takes on more of those routine tasks, human developers will need to focus on the bigger picture, understanding how all of the pieces of a system fit together, anticipating potential problems, making those tough design choices that impact the user experience and the overall success of a product.
So it's not just about writing code anymore, it's about understanding the why behind the code, the principles that drive good software design, and the impact that technology has on people's lives.
Exactly. And this shift in focus will have implications for how we train and educate the next generation of developers. We need to make sure they're equipped with those critical thinking skills, that ability to see the forest for the trees, and a deep understanding of how to create software that is not only functional, but also user-friendly, ethical, and sustainable.
It's a call to action for educators and for anyone who's passionate about the future of software development. We need to adapt and evolve to keep pace with these rapid advancements in AI.
I agree. Now, one of the things that really excites me about this research is the potential for incorporating multimodal inputs. We've talked about how these models are currently limited to text-based input, but imagine if they could also process visual information, interact with user interfaces, even respond to voice commands.
It would be like giving them a whole new set of senses, a richer understanding of the world of software.
Exactly. And it could lead to AI tools that are more intuitive, more versatile, and more seamlessly integrated into human workflows.
It's like moving from a black and white TV to a full-color immersive experience. And the paper also highlights another important area for future research, the economic implications of AI in software engineering.
Right. How will these models affect productivity, costs, job displacement? These are questions that we can't shy away from.
It's like we're standing on the brink of a new industrial revolution, and we need to carefully consider the potential benefits and challenges that lie ahead.
SWE Lancer provides a valuable framework for starting to explore these questions. It's a first step towards understanding how AI might reshape the software industry in the years to come.
And beyond the economic impact, we also need to think about the ethical and societal implications of AI in software engineering. How can we ensure that these tools are used responsibly, fairly, and transparently? How can we prevent bias and discrimination?
These are crucial questions, and they require a broad societal conversation, a collaborative effort between researchers, developers, policymakers, and the public to ensure that AI is used for good, not for harm.
It's a call to action for all of us to step up and shape the future of technology in a way that benefits humanity.
I couldn't agree more. So, as we wrap up our deep dive into SWE Lancer, let me leave our audience with a few key takeaways. First, AI is not about to replace human software engineers, but it is transforming the way we work.
Absolutely. The skills that are most valued in software engineers are evolving, and we need to adapt our education and training to reflect those changes.
Right. And second, we need to think holistically about the impact of AI in software engineering, considering not just the technical aspects, but also the economic, ethical, and societal implications.
This is not just a challenge for software engineers. It's a challenge for all of us. And it requires a collaborative effort to shape a future where technology serves humanity.
I think that's a perfect note to end on. It's been a fascinating discussion, and I'm excited to see how this field continues to evolve.
Me too. Thanks for joining us today, and to our listeners, thanks for tuning in to AI Paper Podcast. We hope you enjoyed this deep dive, and we'll see you next time.